Tenim aquí el Jens Monig, que ve prop de Stuttgart i que és el desenvolupador de Snap i que ens explicarà una mica alguna coseta nova, alguna idea, encara que després amb el workshop de la tarda el tindreu disponible per fer, si no heu treballat gaire amb Snap, una guia més des d'un inici i després també tindreu a la resta de l'equip. Jens, quan vulguis, és un plaer tenir-te aquí i moltes gràcies.
Thank you. Thank you, Joan. Hi, good morning, and thank you for coming and having us again and being interested in what we're doing. I'd like to show something about Snap that we've been working on in the past years, and it's really about exploring the world, kind of like as we've just seen with physical computing. But for us, for Snap, I'd like to explore more the mathematical side, to interact and make sense of our surroundings. And what we're talking about is that sometimes it's easier or more welcoming to not look at the big, wide world, but to look at a smaller part of the world, a micro world in which we don't get lost, and in which we can model certain things to find out how certain things happen. So last night, my friends and I were taking up a walk to one of the volcanoes, the Margarita volcano. That's one of my favorite places here in Olot. And we were inside the crater. This is Feline, Yatka, and Michael. It's a beautiful place, and as we were going out of the crater, we had this spectacular view of the mountains of Garrocha. And this is something that I love coming here, into the mountains, seeing this at night, the way these shapes, the horizon, the different layers of mountains. And whenever I think of coming back to Olot, I'd like to do something that sort of expresses how I feel when I'm in Olot. And so this is what I'd like to explore in a little micro world, to find out how we can experience mountains in Snap. So a micro world in Snap is something where I have just a few blocks, so not all of the 200 blocks, only the ones that I need to tell a story, and those are blocks I made, and some of them are built-in blocks. So one thing when we look at this landscape is that, yes, it could be designed, somebody could have designed it, but it seems to be pretty random, pretty arbitrary, right? Like, this isn't a sculpture. So it might have something to do with a random number. So we have this random number block. Whenever we click on it, we get a different random number. We can set, it should be a random number between, for example, 0 and 200. And so I get a different random number whenever I click on it. And so here's a list block. And so what we have in Snap is when I have a list, for example, a list of zeros, and I put a list in here, now I'm getting a list of 3 random numbers in between 0 and 200. Another way to make a list is the reshape block. So if I'm having 0 reshaped to 4 rows and 3 columns, I'm getting a little table. If I just only need a single list, I don't need the second dimension, I could say. Now I get a list of 512 zeros. And I could put that in here. So now I'm getting a list of 512 random numbers. And I have this little block that shows me these numbers, that just plots it on the screen. So, yeah. So I have a lot of random numbers. It doesn't look like the mountains yet. So it must be more towards random shapes. So one thing that's interesting is that, so now I have a lot of random numbers, and I'd like to scale this list. So here's a stretch block I made. Actually, let me first assign some random numbers to this. I'm going to assign the random numbers here, and I can plot them again. So 512 random numbers. I can stretch, for example, here's a list. I have the numbers 1 to 10. If I stretch that list by 3, so when I get, whoops, 111, 222, 333, right? So I'm just repeating it. If I stretch it by 0.5, it goes the other way. So I'm only getting every second number. So with this noise, I could say, I'm just stretching this by, let's pick maybe a fraction by 1 by 32. So now I'm just getting a few numbers, and I could maybe look at these numbers. So maybe these were just too many. So I'm stretching this. Just a few numbers. But that doesn't look like mountains either. That looks more like New York City. So what would happen if I again, zoom this or interpolate and smoothen this thing that I have? So I made this little block that is a zoom block. So if I zoom what I have here by, 3, for example, now I'm getting little values in between. If I zoom it by 10, it gets kind of more fine-grained. And if I zoom it by the same number by which I divided it, I'm getting another list of 512. And so it's the same size of the list I got before, but it's looking more like mountains, right? Not quite yet like Garocha, but it's beginning to feel like something. So here's this story that how somebody, a kind of computer scientist, tried to do this in the 90s. His name is Ken Perlin, and he invented the Perlin noise algorithm. And I'm going to show this to you. So what Ken Perlin said, what if we take the numbers from 1 to 10, but we kind of reverse them? We start with 7 to 0, so it's sort of a countdown. And we take these as powers of 2. So now we have the powers of 2 reversed. And then we can use map. And now what we do is, we stretch the random numbers by this list of numbers. So we get several lists, the shortest one, a longer one, so they keep growing. But what then if we do the same thing and we again zoom them so they're all the same size? So now I'm getting a list of 8 lists that are all the same size but different resolutions. And what if I then average them? I turn them into one list again, with the one trick that I'm treating the last one, I'm giving it more weight. The idea of a weighted average, the one that's the last list weighs more than the first list. So here's a weighted average block. If I do this again, so now I have a single list of 512 again. What if I plot this? Oh, this is interesting. This is beginning maybe to look like a mountain. So this algorithm is called Perlin noise. I'm going to make a new block in Snap. I'm going to say this is a list block. It's going to be a reporter. I'm going to say this is Perlin noise, and I want to give it a width. Width is called W, and height. And width is going to be an input, as is the height. So now really what I need is, I want to make the random numbers a variable of this function. Random numbers. I'm just putting this in here. And I'm putting this in here that I've just tried. This is my algorithm. So now all I need to do is replace the 512 for my width, and whichever height I want to do is the 200. So now I have a block. I've made my own block. That is a Perlin noise block. Let's try it out. Let's try Perlin noise. The width 512 and 200. Click on this. Yeah, so I'm getting different sort of mountains with this function. And that's kind of interesting. So now I have this mountain range that kind of looks like my view. And I can now explore with the concept of a loop. So here's a for loop. You all know the for loop. You know, you take the variable start to end. And if I use it like this, it counts up from 1 to 10. Sometimes it's also fun to do a countdown. So I'm going to reverse this. I'm going to say count down from 15 to 1. And what I'm doing is I'm putting the Perlin noise inside this loop. I'm clearing this. And I'm saying, you know, okay, let the height be some variable. So I'm saying the height is going to be I times 25. I'm going to start with a really light color, something like this. And at every iteration, I'm just going to make it a little darker. I'm going to reduce the brightness of the pen by slightly. And let's click on this. Okay. So this is almost like, it's kind of beginning to be like Garrocha, how I feel about being here, the view from the Santa Margarita. And so this is a little micro world in which, with a few blocks, I'm trying to find out something about the actual world around us. And it is about experience. And experience, I'm from Germany. The German word for experience is erfahren. And that literally means to move through things, to travel through things, to change one's point of view, to change one's perspective. So it took a while for us, for me especially, to notice the name of the residency we're staying in here in Olot. It is the Faber-Yui residency. I don't know who Faber is, and I don't know who Yui is, except somebody told me. Wait, now I've kind of already said it. So there's this book that we all read, that we all love, that Brian taught for 25 years, The Structure and Interpretation of Computer Programs. And at one point, my friend Bernard told us, look at this guy. This, on the cover of Structure and Interpretation of Computer Program, this is Ramon Llull. And the way he noticed it, because he's having this typical Catalan hat, which is what Bernard said he used to wear. So I went off and bought one. And I bought a bunch of books from Ramon Llull to find out why he was on the cover of this book. And I didn't know, but now I know that he's considered to be one of the founders of computing, of informatics. And kind of one of the big ideas of Ramon Llull was to do dials that you can turn, that you can rotate, so you get the combinations of different dials. So it's really the concept of rotating lists of rotating alphabets. And just to put this off as a last thing, when I try to apply this concept of rotating things, to this. Here's a little script that I made. When I rotate the Perlin noise, I map the Perlin noise we just made. I make a really long list, like 5,000. And the height, I'm mapping this kind of over my 25 again. And when I'm using Ramon Llull's way of turning the dials, of rotating these layers, what I then get is something that is Erfahrung, that is motion, and that is a change of perspective. And it's even interactive. I can move through the mountains of Garrocha, applying the concepts of Ramon Llull. And if you're interested in more of this, in kind of checking out mathematics, come to our workshop this afternoon. We're going to show you all about it. Thank you.